So there's a professor at Imperial College in the UK called Neil Ferguson, who's an epidemiologist and uses computational modeling as part of his toolkit for studying epidemiology. And as the COVID outbreak got started in 2019, 2020, he gave testimony to the UK Parliament based on some modeling that he had done. And this was really significant because it helped prompt the government to take some actions. But in his modeling, there were lots of assumptions, and those might not have been exposed at the level that some people would think appropriate, as we'll get to in a few minutes. And then shortly after, a couple of weeks after, a fellow called Nicholas Lewis, who bills himself as an independent climate science researcher, wrote a piece that said, you know, I can't easily see where some of these assumptions come from, and he publishes a blog article and where he says, among other things, computer code is old, unverified, and documented inadequately, if at all. And so, to be fair, Neil Ferguson actually agreed with this. You know, it's you know, the product of their longtime research activities and wasn't necessarily expected to be scrutinized at this level. But you know, this is obviously high profile, so the press now picks up the story. And I've taken some of these quotes from Fox News, but there are other sources that had similar vein on things, right? The headline in the top right, Imperial College model Britain used to justify lockdown is a buggy mess, totally unreliable. In our commercial reality, we would fire anyone for developing code like this. Models must be capable of passing the basic scientific test of producing the same results given the same initial parameters, impossible to reproduce, first of many bugs found, things like that. So a lot of bad press about this, a lot of pushback on the work that was done. What you may not have heard was subsequent to that, first of all, right almost at the beginning, as soon as this code was released and became prominent, Imperial started working with Microsoft to refactor and clean up the code, which they released on GitHub April 22nd. And so that was a new, you know, a refactoring of the code, cleaner version that was made public. Fellow called Phil Bull rebuts the criticisms of the Imperial code. He said basically, many scientists write code that's crappy stylistically, but it's nevertheless scientifically correct. Professional commercial software developers are well qualified to review code style, but most don't have a clue about checking scientific validity or what counts as good scientific practice. So he called into question a lot of the comments that were made by other software engineers looking at the code and things like that. And then maybe the last piece of the story was a little bit later in May. There's an independent organization in the UK called CodeCheck that reproduces important results, and they were able to take Imperial's code and their data and reproduce the results that appeared in this report, which was effectively the testimony that Neil Ferguson gave to the UK Parliament. So these are things that didn't get as much press, but it's in many respects, you know, a good end to the story. But there's some lessons here. I think your code is likely to live longer than you expect and may be used in ways that you don't expect by people you don't know, right? And you should plan for that. This, you know, depending on the domain you're in, this is maybe more likely in some contexts than others. But the longevity of code is not questioned, and the fact that, you know, if you move on from a project, it can be used, all kinds of things can happen to it, and you really have no control and may have no knowledge of what's going on with the code. And related to this, and one of the reasons why this epidemiological model was so important and so intensely scrutinized was because increasingly we make consequential decisions based on purely computational results. So in my opinion, the codes generating those results may be justifiably subject to greater scrutiny. I think that's worth, it is worth examining what goes on in these codes if we're making important decisions based on them. We go back to this mantra that I started talking about in the overview talk. Scientific credibility of your software is connected strongly to the software engineering practices used in your code and development. And in this case, we saw particular questions about the documentation and lack thereof. We saw questions about the level of testing and the reproducibility of the results. This was a Monte Carlo model, so that led to some of these. We had a discussion a little bit earlier this afternoon about reproducing non-deterministic codes, which was one of the things that came up when some people were looking at it. And then just general code quality and readability. So just it was crufty code and people had a hard time understanding it. But then we go to Phil Bull's rebuttal, and should we excuse scientific software for being crappy stylistically? And we had an extensive discussion within the Ideas Project about this, and I think the conclusion that we came to is the important thing to remember here is that crappy code makes it easier to hide bugs. So in scientific software, crappy style is a good way to hide bugs, and that's probably overall something we should not be encouraging in our software, something we really want to root out where we can. So we come back to this mantra: science through computing is at best as credible as the software that produces it. Very important consideration. We talked about a lot of topics that we think factor into this: project management, collaboration around software development, especially with respect to Git workflows for teams to work together, software design considerations, testing strategies from the basic to the complex, refactoring of large complex software systems, continuous integration, and reproducibility considerations themselves. There's a lot of other things that we didn't have time to cover today. Documentation, licensing, packaging, and distribution of software. There's a whole list here. There's a few reasons, as I alluded to earlier in the morning, why we're not talking about these. One, we don't have time to cover everything. These, we think, are aspects where there's less of a distinction between research software, scientific software, and other types of software. So a lot more of the advice that you can find online and in books and elsewhere that pertains to software engineering practices for general software is much more usable also for scientific or research software. There are also a lot more informational resources available that talk about these topics. And in many cases, these are a bit of a second level concern for early career researchers. And so we had to kind of pick and choose what we could cover in a, 6-hour day or something like that. And so this is where we've ended up. But you say you're a researcher and you can't afford to spend all of your time just doing the software engineering crap. And so I'll go back to this recommendation that we've talked about a couple of times to focus on having just enough software engineering in your project to meet your short-term and longer-term goals effectively. And I think it's important to think about the longer term. I like to think of software packages, scientific software, as a research tool, and I want that tool to be long-lived and to be able to adapt to my research program over time. And so I do want to think about the longer term. I'm not just interested in the next paper or the next grant proposal cycle or something like that. And we have this process that we suggest of continual but incremental improvement in your software processes. So once again, look for the pain points that your team is experiencing with respect to the software development practices. Pick out something and set a goal to improve it. You want to target processes and behaviors, not just tasks, not just we need to improve the documentation, but how do we make sure that every time the code is changed, the documentation is changed to match, and things like that. You want to pick something that you can address in a fairly short time, maybe a few months, so that you and the team can see a noticeable benefit. You're not just grinding on and on trying to work on this thing. That just makes people feel better about the new thing. Agree on a plan to address it. Figure out what constitutes done so that people agree when you're there. Figure out some steps along the way that you can use to track your progress. And then you just work to the plan as you're doing your other activities. It doesn't need to be exclusive of other things. And track your progress as you go along. And when you hit the done criteria, then have a bit of a celebration. And then you can go back and do it again with whatever is bothering you is next up on your list. And so this is something that we have other tutorials that talk about this piece of process. We have some resources online. The resources that we're pointing you to here are on the BSSW site, and the goal of that site, as I've mentioned before, is to provide general resources for software processes that you might be able to adopt, or at least to analyze what would be useful for your own project. You probably have experiences or know about resources that we haven't covered yet in BSSW. So, you know, we're collecting resources as we go along, but there's lots of stuff out there. So please consider contributing based on your own experience. It's pretty easy to do. And so the last thing I'll ask you is to please let us know how you thought about the tutorial. I believe that the whole ATPESC has a survey too. Please make sure to respond to that, but we welcome specific feedback about our track. If you want to work on some of the hands-on activities that we've mentioned throughout the day, we'll provide feedback. You can put pull requests in the repository or issues, or you can email us. We have the website for the tutorial, which will be long-lived. And then if you've heard enough interesting things about what we're doing and you're interested in following along, down here on the bottom are ways that you can follow both the Ideas project and new content on the Better Scientific software site. And with that, we are done with the planned material for the day. And the whole team is happy to take more questions or discussion. And we thank you very much for your attention, the good questions and discussions we've had all day. And we hope you find this a useful experience.